Assalamualaikum and a very good day to all. Today our group will be presenting on the multi-purpose hanger. The group consists of 3 people. First I'll be presenting, which is Muhammad Faiz bin Nordin, followed by Muhammad Azinuddin bin Dahlan, and the last presenter for our group would be Muhammad Zulfazli bin Raub Khan. Basically, the presentation would be divided into 2 parts. The first part will be on the requirement analysis, whereas on the second part would be the QFD, which is the quality function deployment. An introduction into the multipurpose hanger. A clothes hanger, a coat hanger, or a coat hanger is a device in the shape of a human shoulder which is designed to facilitate the hanging of a coat, jacket, sweater, shirt, blouse, or dress in a manner that prevents wrinkles, with a lower bar for hanging of trousers or skirts. Basically, this part of the requirement analysis objective is to first identify all the customer's needs pertaining to our multi-purpose hanger. Second is to evaluate the system for its feasibility. Third is to perform economic and technical analysis. Fourth is to allocate functions to system of developments. Fifth is to establish all the constraints. Sixth is to create a system definition and specification. Often in the requirement analysis, it involves 3 types of activity. Number 1 is to gather information or data, which is in simple terms we can say as a survey. Survey is being done to 105 respondents, each in identifying what are the customer's needs in terms of the multipurpose hanger. Second is to translate all the data into meaningful design parameters to focus on, namely a Pareto chart or a Pareto diagram. And the third type of activity is the documentation or documenting the design parameters, which is what we call and what we can say is to do benchmarking. In clarifying the problem, there are about 105 respondents being conducted on for this survey with what type of problems which you face during the hanger or using the hanger. From the responses of 105, we can identify there are 6 items which contributes to the problem statement. Extracting the findings from the survey, it can be highlighted that the existing hangers have the following issues which needs to be addressed according to the problem statement. The first one is not being able to withstand heavy clothes or garments, especially during wet. Number 2, the unavailable to accommodate several numbers of clothes or garments with different sizes. And the third is it is bulky in size and it is not able to transfer easily and quickly from inside to outside of the house and bring them along comfortably when traveling. The fourth problem statement is consuming large area in the house and when not in use where the storage is of main purpose. Number 5 is the insufficient time to accommodate numbers of clothes or garments at one time. And the 6th problem statement is not durable to sustain various conditions of weather and environments without much effect. Looking at design objectives for the multipurpose hanger, the existing clothes or garments hangers have compromised with below qualities. Therefore, our proposal design will have the following key features, such as number 1, strength, where it is able to withstand heavy clothes or garments, especially during wet. Number 2, it is resizable. The multipurpose hanger is resizable and they are able to accommodate several numbers of clothes or garments which is of different sizes. The third design objective for the multipurpose hanger is the mobility, which is the ability to transfer easily and quickly from inside to outside of the house and also to bring along comfortably while traveling. The fourth design objective is compactable, where the multipurpose hanger needs to be compactable and it is able to be stored in very minimum space while at home or during traveling. Fifth, or number 5, is the quantity of the multi-purpose hanger. It is able to accommodate a number of clothes or garments at one time. And lastly, number 6 is its durability, where it is able to sustain various conditions of weather and environments without much effect on the purpose itself. So as for today and now, we have looked into the introduction, the problem statement, the design objectives, and next we'll be looking at the global market survey, local market survey, market demand, and the product improvements. The market survey is partly associated with benchmarking. So for our multi-purpose hanger, the global market survey and the local market survey is being done. For the first competitor, you can see that there is a horizontal suspension, a vertical suspension, and a rotatable hook type of hanger being sold, and you can get them in AliExpress for about $1.57 to $4.81. For the second competitor of the global market survey, the specification of the hanger is that it is being made of a material called plastic. The size of it is the unfolded between 47 times 47 times 2 cm, and the size after shrinking is about 47 times 9 times 2 cm. It is in large capacity and it can hang about 13 clothes. So this is what we are trying to implement, or the benchmarking being done to a competitor's product, where we will be incorporating it into our multi-purpose hanger. So the price is about $4.46 and you can get it in aliexpress.com. The third and fourth competitor is among the local market survey being done, where the price of the hanger is about 20 ringgit to 35 ringgit. And the fourth local market survey or competitor is, the description is that it is a multifunctional folding plastic clothes hanger for clothes which have 8 ranks set. The price being sold for this type of hanger is between 15 ringgit to 25 ringgit and can be exclusively purchased in Alibaba.com, where the supplier is the Langfang Nice Trading Company Limited based in China. For the market demand, it can be seen here, it is being extracted from the questionnaire being given to the 105 respondents pertaining to the multi-purpose hanger. Same goes to the product improvement, where the product improvement is being extracted from the questionnaire, and the product improvements can be seen here. Then, for example, if do you prefer the hanger to be expandable in terms of size? Yes, 87.6% of the respondents accept it and requires it to be done. The last two product improvement shows that majority of the respondents would like to have what the multi-purpose hanger has on the survey. The Ishikawa diagram is used as an assisting tool for the multi-purpose hanger, where it is a cause and effect diagram when it visualization for the categories of potential cause and effect of a problem in order to identify its root and causes in determining the best possible solution for the hanger. Next activity on the design requirement analysis is about designing a Pareto diagram based on the features of the survey, which is strength, resizable, mobility, compactable, quantity, and durability. These are the features which is on the top list of the survey, with the frequency of the strength is 69. Cumulatively, it adds to a resizable of 137, mobility is 202, compactability 248, quantity is 282, and durability is 307. In analyzing the Pareto diagram, the requirements used is for the Pareto chart is 80% to 20% rule, which is 80% effects and 20% causes. If you look at the Pareto diagram or Pareto chart here for the multi-purpose hanger, there are 4 features which needs to be inside or looked upon in order for the multi-purpose hanger to be relevant, which is the strength, the resizable, the mobility, and compactable, This is according to the 80-20 rule, 80% effects and 20% causes. The 20% cause is for the quantity and durability which can be neglected. Moving on to the second part of requirement analysis is the QFD, which is the house of quality. The QFD is a matrix-based decision analysis tool where it emphasizes on the customer's interaction and leads to a better product. This is based on the survey and we can generate it through the QFD. And in other words, it opens the door for better innovation analysis for the multipurpose hanger. For the multi-purpose hanger, what can be seen is that the importance is for the resizable and to be different in sizes plays a very particular role, which is it carries 105 points as compared to 36 of can cater multiple number of garments. This shows that 36 can be opt out even if it's not there. The 105 shows totals where the parameter or feature is significant to be brought to the design where it is impossible to opt out compared to the 36. The 111 shows how important the length of extension or retraction for the multipurpose hanger to be brought forward for future design compared to the number of hangers per set, which is only 33, which also can be opt out. Finally, the conclusion which can be drawn on the product development based on QFD evaluation is that number one, resizable features to cater multi-size garments becomes top priority for the design requirement. Second is the space saving and compact design becomes next priority for the ease of storage and mobility purposes. Number three, heavy duty and high durability becomes another criteria to be considered. And lastly, number four is for design parameters, the length of extension or retraction and the degree of rotation becomes important variables to be considered in the design process for future multi-purpose hanger. So from all the requirement analysis, the next presentation will be continued by Mr. Azinuddin bin Dahlan. Thank you.
Thank you to my colleagues Muhammad Faiz for the previous presentation about requirement analysis, Pareto and QFD. Okay, today I will continue our presentations about the function tree and morphological matrix. Our key objective for these presentations is first to create a function tree of a multipurpose hanger, second to construct a morphological matrix of a multipurpose hanger, third to propose 4 alternative design concepts of the product, fourth to access the proposed concept design that meet the desired targets. For your information, our targets are prices, space savings, portability, aesthetics, and multifunctions. Last but not least, number 5 is to analyze the differences between selected design and discarded design. Okay, let's go to the function tree. Okay, these are the function trees that we constructed based on our product design, which is multi-purpose hanger. As you can see here, we have 5 elements of the function trees, which are materials, flexibility, aesthetics, compartment, and accessories. Under materials, we will look into type of materials, strength, weight, cost price, and corrosion resistance. Meanwhile, for the flexibility, we will look into the expandable, foldable, portable, and hanging style. For the aesthetics, we will look into the texture, shape, finishing, and surface features. For the compartment, we will look into the hanging capacity and storage types. Last but not least, the accessory we will consider for the various components that can be attached and detached to the multi-purpose hanger. Okay, let's go to the morphological matrix. The morphological matrix, we have tabulated, brainstorm 5 ideas based on the sub-function of the multipurpose hanger. For the first subfunction, which is material, ID number 1, we look into the aluminium, ID number 2, fabric, ID number 3, wood, ID number 4, plastic, ID number 5, composite. For the next subfunction, flexibility in terms of expandable and retractable, ID number 1, pivot, ID number 2, snap fit, ID number 3, bolt and nut, ID number 4, hinge, and ID number 5, pin and clip. For the next subfunction, it is flexibility in terms of hanging style. ID number 1, incline. ID number 2, horizontal. ID number 3, vertical. ID number 4, looping 360. And ID number 5, curvature. Please take note that the color in idea column depicts the difference combination for matrix of concept number 1 until number 4. So let's go to the next subfunctions of the morphological matrix. The subfunction aesthetic in terms of shape. ID number 1, triangle. ID number 2, rectangular. ID number 3, round. ID number 4, semisphere. And ID number 5, multi-shape. For the next subfunction of aesthetic in terms of surface features, ID number 1, anti-slip. ID number 2, anti-rust. ID number 3, waterproof. ID number 4, hollow. ID number 5, solid. And the next subfunction is in terms of compartment, hanging style or hanging capacity. ID number 1, single hanging. ID number 2, double hanging. ID number 3, multiple hanging, slotted. And ID number 4, multiple, unlimited. Okay, let's go to the next subfunctions of morphological matrix. In terms of compartment storage style, ID number 1, single U-shape. ID number 2, vertical upright. ID number 3, umbrella style. ID number 4, curve. Last but not least of the subfunctions, which is accessory, variety components that can be attached and detached to the multipurpose hanger. ID number 1 is suction cup. ID number 2, clippers. ID number 3, double hooks. ID number 4, rope line. Okay, based on these ideas, we generate our concept design. Our concept design comprise of 4 types of concept. Let's go to concept number 1. Okay, this is the concept number 1. The concept number 1 for the subfunction and function consists of first composite, second pin and clip, horizontal, semisphere, anti-rust, or quoted, single hanging, vertical upright, and rope line. In this slide, you can see the justification for the selection of ideas for concept number 1. For example, composite. For idea number 1, for concept number 1, the disadvantage of this material slightly expensive due to combination of different materials. However, for idea having clip and pin and clip, they are user-friendly, simple to operate, but limited to hanging capacity. Another advantage for the concept number 1, we have anti-rust or coated, which resists the highly moisture ambient. For the disadvantage of idea number 1, having vertical upright, disadvantage. Single hanging, the disadvantage of high drawback due to limited capacity. That's all about the concept number 1. Let's go to the concept number 2. Concept number 2, the elements of the subfunction in concept number 2 having wood, bolt and nuts, looping 360s, rounds, solid, multiple, unlimited, hanging capacity, curve, and suction cup. The justifications for this concept number 2, the disadvantage of wood, most expensive due to high quality of wood. Bolt and nut, they also give you disadvantage, troublesome and not user-friendly. Looping 360s consume larger space to accommodate loop. This all the disadvantages. So we go to the concept number 3. The concept number 3, the elements of the subfunctions consist of plastic, pivot, inclined, triangle, hollow, multiple, umbrella, and clippers. The justification for concept number 3, for plastic, we have the advantage, which is the cheapest among the other material. Pivot, allow 360 rotations and maximize space for hanging purpose. Hollow, lightweight and good for traveling. Umbrella, space saving when not in use. That concept number 3. Let's go to concept number 4. The element for concept number 4, having aluminium material, snap fit, vertical, rectangular, antique slip, double hanging, single U shape, and double hook. The advantage of this concept, snap fit, allow easy expansions, retraction, and user-friendly. Anti-slip, good for silk or smooth texture clothes. The disadvantage of this concept, double hanging, limited capacity, aluminium a bit expensive compared to plastic. So based on these 4 concepts, we do the assessments and of the criteria based on the price, space savings, portability, aesthetics, and multifunctions. From these elements of criteria, we found out that concept number 3 is the best for us to proceed with the design. Because of the elements of cheapest ABS plastics, highly space savings, very portable due to umbrella design, aesthetic looks with modern design, hollow shape, and the other features such as 360 rotations of pivot, multiple slot for hanging, clipper for small garments. However, the discarded concept in these 4 design concepts, we found out that concept number 2, which is not that favor to us because of the most expensive, not space savings, not portable, and so on. So with that, we continue our design with concept number 3, and we discarded the design for concept number 2. As you can see in the next slide, we give the rating for the concept, whereby we can see here the highest score for the ranking is concept number 3 with 88. And the lowest score for the concept is concept number 2 with 47. And you can see here the factor that we gave to the criteria, price and multifunction, is the highest with the 5 factor. Portability 4, and space saving and aesthetic 3. So we can see here the ranking. The concept number 3 is the chosen one, number 1. Concept number 4, second. Concept number 1, number 3, third. And concept number 4, fourth. Okay, these are the summary of the concept. Accepted solution, concept number 3, because the cheapest, modern design, very portable and space saving, enable 360 rotation and added multiple slots. Discarded solution, concept number 1 and 2, not feasible, consume space, storage-wise limited, not handy, and requires a lot of attention to use it. I would like to say thank you for your attentions, and I will pass to my another colleagues, Zul Fazli, to present the Topsys. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Now it is my turn. Muhammad Zulfazli bin Rauhan would like to present you a technique for order preference by similarity to ideal solution, or simply known as Topsys. So what can you expect from these presentations? I would rather to say that before this we have been through for the function tree, the morph matrix, and now we are focusing more on pivot matrix versus Topsys for product concept generations for multi-purpose hanger. So since this is a presentation which contains the additional contents, so I can say that in the key objective throughout this activity, I have added the 5th objective, which means to analyze and evaluate the conceptual designs using different tools such as pivot matrix and Topsys. So we're going to see how does these 2 tools actually plays their roles and give a guidance towards our evaluations, and towards the end how that can guide us to select the best options, which is far from the risk or cost and very close to the benefits. Okay guys, moving on into the first style of the Puth matrix, we can say that we have two important parts here. The first one is the factors or the weightage, and the second one is the scoring systems. Okay, you might ask me why we have to apply the factors or the weightage on the criteria. So simple answers, because we want to represent the significance of the criteria over another criteria. Okay, and what can you see here, that the space saving having the weightage of 0.1 and the hanging capacity is 0.2. Okay, so with the different numbers of the weightage of factors, it shows that the hanging capacity in this case, however, is more significant towards the space saving criteria. Okay, moving on the scoring system, instead of normally in the Puth matrix we are applying a positive, negative, and or even equal signs. So I would prefer to have a numerical presentation because it gives a straightforward comparison in terms of numbering from one concept into another concept. Okay, on top of that, I would like to say that the summations or the total sums of the weightage, it must be equal to total score to 1.0. Okay, what are the best part of using the Puth metric is it allows a normal user, okay, to come up with a straightforward answer, because it doesn't contain any sophisticated or complicated calculations. So in this case, you can say the concept 3 score with a 2.5, followed by the concept 4 with 2.3, and then followed by the concept 2, which is 1.6. So in terms of ranking, we would like to rank them. Once again, the concept 3 will be the first rank, followed by the concept 4, and then concept number 2. Okay, moving on into a second style of the Puth metric. What can you see here? We have removed the weightages that has been applied before this in each of the criterion, and now we change the concept 1 to be one of the concept to be evaluated, and we choose a magic hanger as a datum. So obviously and literally, I would say that when you do not apply any weightages or factors on each of the criterion, so you can assume that each of the criterion now are having a same significance towards a different style of the concepts. And frankly speaking, that again the concept number 3 would have a higher score with a number of 14s, and then followed by the concept 4, 13, and followed on the third place is followed by the concept number 1 with the total score of 11, and however the concept number 2 become in the ranking of number 4 with a total score of 10 only. So in top 6 we have 8 different steps. Start with the step number 1 up to step number 8. You can't skip any of the step, and you must follow step by step in ascending order. Okay, so in the first step you have to come up with a decision matrix, and in step number 2 you have to quantify the qualitative criteria into a numbers, so then you can make a calculations towards them. And then step number 3, non-dimensionalize the attribute value, because this is quite important, because some of the numbers are not really what can you say in the same fashion. So we would like to have a normalizations of the patterns of the numbers, and follow up by the step number 4 we have to assign the weighted value for the attributes. So this is very close to the one that we have applied before in the Puth matrix. We apply different weightages or different factors into a different criteria, and followed by next step number 5 we have to establish the ideal, which is the most positive ideal and negative ideal solutions. And step number 6 we have to calculate the separation distance. So in this step we have clustered them into two parts. The first one, the separation distance of the positive ideal solution and negative ideal solutions. And step number 7 we have to calculate the closeness rating for each of the concepts. And last but not least, in the step number 8 we might come out with the rank of the concepts. Zooming in into step number 1, which is creating a decision matrix. So in this case, I would literally say that this is quite equivalent to the one that we had in the Puth matrix. It's just a matter of tabulating them in a different directions. Before this, we have a concept 1 to 4 in terms of vertical order. Now it is being put horizontally, and however we have 1 to 6 different criteria is putting in vertical order. So the criteria that we are choose basically is cost, mechanism, spacious, capacity, portability, and multifunctions. Moving on into a step number 2, quantify the qualitative criteria. So as compared to the Puth metric, because this is being taken straight away from the Puth metric as well, so we don't have any problem since we are using a numerical representations. So we don't have to transform a qualitative into quantitative criteria. However, if you have a look in the Puth metric, we are using a scoring system of number 1, which is represent the lowest, number 2 the medium, and number 3 is the highest. But in the TOPSIS, we have to avoid that because we have come out on the first time, and seems that most of the ranking are not really in what we are expecting for. So we change the scoring system in the TOPSIS. Instead of 1, 2, and 3, now we are choosing 3, 6, and 9, which means that 3 are representing the lowest, 6 are representing the medium, and however 9 representing the maximum score. On into step number 3, non-dimensionalize the attribute value, or in simple word we can say normalize the numbers. So since in step number 2, thankfully we have been using same versions of a number, which is 3, 6, and 9. So giving you some example, how do we get on the first criteria, which is cost versus concept number 1, with the score of 0.37796. This is simply comes back into a step number 2. When you go into under criteria cost versus concept number 1, you will have a score of 3. So you are taking out this number 3, divide by the square root of 3 squared plus 3 squared plus 6 squared and plus 3 squared, and finally we give you to the number of 0.37796. Step number 4, we have to assign the weighted value or factors for the attributes. So I would rather to say that this is very important and reflects back to the Puth metric. We have assigned same numbers of the weightage at cost 0.2, mechanism 0.1, spacious 0.1, capacity 0.2, portability 0.2, and multifunction 0.2. This is exactly the same of the weightage that we have been applying in the Puth metrics. So when you have a numbers of 0.2 and then multiply it in the step of number 3, let's say we go for the concept number 1, which is 0.37796, multiply of course with the weightage assigned, it will give a number of 0.07559. Moving on to the step number 5, establish the positive ideal and negative ideal solutions. Of course, for the mechanism, spacious, capacity, portability, and multifunctions, we have to bear in mind the highest the value will represent the positive ideal solution, and the lowest the value will represent the negative ideal solutions. However, on the other hand, for the cost items or attributes, is going to be working all other way around. The highest the number will represent the negative, and however the lowest number will represent the positive value. So speaking of that, step number 5 has to be linked up into the step number 4. I have putting in the color which represent the green one represent the positive ideal solution in the step number 4, and then the what we call an amber color will represent a negative ideal solution. So putting the value, tabulated them, and we're going to have the step number 5 as easy as that. Okay, now we are moving into step number 6, calculate the separation distance. And of course we have to use the formula given to calculate the separation distance. Is simply the square root of the summations alternative value minus the positive or negative ideal solution and squared. Alright, so what can we say here? That we have two parts of the separation distance. Either it is moving towards positive ideal solution and the other part is moving towards negative ideal solutions. And of course, for the separation distance, this is being calculated for each of the concept, which is concept number 1, 2, 3 and 4 has to be calculated separately. Okay, so in a simple term, what can I say? That the positive ideal solution and negative ideal solutions, they are really working in the other way around. And from here you can say that the concept number 3 possess the lowest value of the positive ideal solution, means is very close to the positive solutions, and in fact on the negative separation distance it has the highest value. It shows that it is far away from the negative ideal solution. So I can say in step number 6 you're gonna have kind of imagination that the concept number 3 will possess on the first rank. Number 7, we comes to calculate the closeness rating, and using the formula where you have a separation distance of the -1 divided by the summations of positive and negative separation distance. So what can you say here? The concept number 3 produce the highest number of 0.7, followed by the concept number 4 0.5, and then concept number 1 0.4, and last but not least concept number 2 0.3. And straight away you comes into step number 8, ranking the alternative based on the closeness rating. You're gonna have the concept number 3 as will be on the first rank, followed by concept number 4, and then concept number 1, and lastly concept number 2. By using the TOPSIS, it is basically focusing on the product that comes with the lowest positive ideal solution. It shows that you are very close to the positive ideal solution, so we are aiming for the lowest number of the positive ideal solutions, and at the same time you must have a high number of negative ideal solution, because you want to go far and far away from the ideal solution. As frankly speaking, by comparison, Puth evaluation metrics compared to the TOPSIS evaluations for the multi-purpose hanger, absolutely I can say that concept number 3 will be on the first rank, since on the Puth or the TOPSIS are really supported the same result. Okay, and however in comparison we can say that concept number 2 will be on the lowest ranking, because they are producing the lowest score both for Puth and TOPSIS. Okay, from a different perspective or angle, what can I say? Puth metric versus TOPSIS. Basically the Puth metrics are comparing one concept number 1, 2, 3 and 4 is being compared to a datum, which is a datum that we are taking out from the list of competitors. In fact, the TOPSIS, they are not using any datum or any competitors out there, but they are comparing from concept number 1, 2, 3 and 4, between 4 of them, and they are hardly using all the importance formula to come up with the ranking. Concept number 3 is mainly being chosen and is being proven by the TOPSIS, or even the Puth metrics is one of the good concept to be working on, because it is cheapest. It's based on the ABS plastic. It has a good features, highly space saving in due to the inclined hanging style, and of course it's very portable due to umbrella design for traveling, so it can cater for the frequent travelers as well. And of course for a sail margin, it has an aesthetic look with the modern design, which embed with the latest design of the hollow and 360 rotations of the pivot, multiple slot for hanging, clippers for small garment. This is going to be the support the multi-functions of the modern multi-purpose hanger.
Okay, so following a result from TOPSIS, we have come up with the concept number 3, and here we are glad to present you a conceptual design. We can say a hand sketch of a multi-purpose hanger, which is been translated from TOPSIS result actually. So the first one is a rotational 360, which provide extra flexibility, you can see here, and hanging hole, which it can increase the hanging capacity. Extra hook, basically it can help you to hook different types of garments, and of course we have the adjustable length, which is this is a extra features which you can hanging on a multi-size of garments. And of course, last but not least, you have extension and retraction mechanism. This is the most important one, which helps you to make your hanger in a compact, easy storage and mobility.
Last but not least, create a good product. Select how to select a good product. Actually, it start with the come up with the requirement analysis, and we go to the Pareto, and of course we table out the QFD, quality functions of deployments, and then from there we are going to take out the important criteria in terms of what are the customer demands versus the engineering parameters to be looked forwards, and we bring it into the functions tree, and from there we table out and we detail out all the important criteria. And of course in the morph matrix we have come up with different ideas, and then we are able to generate a different concept, and in this case we have generated 4 different concepts for the multi-purpose hanger. And thankfully to the Puth matrix, is really a straightforward evaluations. In this case we have come out that the concept number 3 is going to be on the top rank, and however concept number 2 is going to be on the last rank. And this evaluation has been reinforced by the TOPSIS. Of course I would prefer the TOPSIS because it really make a comprehensive evaluation in terms of positive ideal solutions, in terms of the separation distance itself, and in terms of the closeness rating. So what can I say, that we are looking into a product not with the highest score, but in fact we have to counter check and counterbalance of the positive parts of the product itself, in this case the positive ideal solutions, moving towards the positive ideal solution, which give you the most benefit of it, and this has to be maximized, and at the same time we have to minimize the cost, and the TOPSIS will be one of the good tools. Thank you very much.